Hello everyone. In this video I am going to demonstrate FSK modulation and demodulation technique. So as you can see here, this is my FSK modulator and demodulator. Half of this circuit is the FSK modulator, up to here is the FSK modulator, and up to here is the FSK demodulator. Both the modulator and demodulator are tested on a single breadboard. So as you can see here, this LED is flashing and it is receiving the data from Arduino Uno. You can see this white IC, this is the optical isolator MCT2E. The output of this optical isolator is fed to this transistor SL100. This transistor is responsible for selecting two frequencies, F1 and F2. The F1 frequency is 11.90 kHz. This is for logic 0, and F2 is 1.3 kHz. This is for logic 1. So as you can see, this transistor is responsible for selection of two different frequencies. I will show the circuit diagram, then it will be very clear how this frequency selection is being done. The output of the modulator is coming from pin number 3. So this is the final modulated FSK frequency shift keyed signal. So as you can see here, Arduino Uno is throwing 9600 baud data continuously, and here this LED is receiving the data and it is optically isolated, and the data is based on the data, the proper frequency is selected by this transistor, and the proper RC combination is fed to 555 timer IC on a stable multivibrator mode. The output of this 555 timer IC is the final FSK modulated signal. Let us look into the circuit diagram for the FSK modulator. So as you can see, this is the circuit diagram for the FSK modulator. So from my previous video, this circuit is pretty different. I have changed the RC values. So as you can see here, this is the Arduino Uno setup. The transmit pin is connected here and it is optically isolated. So the modulator is basically optically isolated from the Arduino Uno. So as you can see here, this transistor SL100 is responsible for selection of the two frequencies. So when the value here is 0, it will send one frequency at the output, and here when the value is 1, it will send another frequency. So there will be a switching between the two frequencies F1 and F2. F1 is 11.90 kHz and F2 is 1.3 kHz. So this is how the selection of frequencies is done using this transistor. So finally the output of the 555 timer IC is the modulated FSK data. Let us look into the modulated FSK data on the oscilloscope. As you can see, this is the raw waveform obtained. Let me zoom this waveform. So upon zooming, you can see this is the waveform. So this is the FSK signal. You can see there is a change in frequency in the signal. This is the FSK data. This is the FSK modulator output, and this is the final output. So we will not talk about the final output now. So you can see this is the FSK modulated signal, the yellow pen. You can see there is a change in frequency. This is the high frequency. Here is the low frequency. You can see there is a change in frequency. So this is the FSK modulated output from the pin number 3 of 555 timer IC. Now let us look into the demodulator unit. The demodulator unit consists of RC filter. So as you can see here, this is the RC low pass filter. You can see this 10K and 0.01 microfarad, they are forming the low pass filter. So as a result, the 12 kilohertz frequency is filtered by this low pass filter. So this low pass filter is designed to work at a frequency of the cutoff frequency of 1.5 kilohertz. So since the frequency of since the F1 frequency is 12 kilohertz, it will be blocked by this filter. So high frequency components will be blocked by this filter, and the low frequency components will be allowed to pass through. So after this filter, there is a envelope detector. You can see this is an envelope detector. So the output of this filter is connected to this envelope detector. You can see this is the close view. So this is an envelope detector. This is the Schottky rectifier for the envelope detector, and here is the capacitor and RC network. So output of this envelope detector is finally fed to this, you can see this op-amp LM339 voltage comparator. So the voltage comparator is fed to, the output of this envelope detector is fed to this voltage comparator, and one pin of this voltage comparator is fed with a fixed DC supply. Upon comparison, the final value is fed to this SL100 transistor, and the output of this transistor is the final data. So let us look into the demodulator circuit, then I will show you this circuit again. It will be very clear. So as you can see, this is the demodulator unit. You can see from the pin number 3 of 555 timer IC, this wire is connected directly to the low pass filter. So this is the low pass filter, 10K and 0.01 microfarad. The cutoff frequency of this filter is 1.5 kilohertz. I have made a separate video for this low pass filter. The output of this low pass filter is fed to this Schottky rectifier. This is a high frequency rectifier, and the output of this rectifier is fed to this capacitor and resistor network. So basically this whole unit is the envelope detector. You can see this whole unit is the envelope detector, and at this point the voltage here is greater than 2 volts DC. The pulses will be greater than 2 volts DC. So as a result, we have a voltage comparator over here. This voltage comparator is set to a voltage of 2 volts DC. So whatever voltage comes here above the 2 volts will be coming here. So this is a simple voltage comparator made of IC LM339. The output of this comparator is again fed to this SL100 to rectify the logic state, and here comes the final data. So this is the circuit diagram of the demodulator. The demodulator is pretty complex because the envelope detector voltage and the comparator voltage must be properly tuned, else we cannot get the proper data. You can see, so this is how the demodulator looks like. This is the demodulator. So this is how the demodulator looks like. So now I am going to show you the demodulator again in the circuit. So here you can see this is the RC. This is the low pass filter I was talking about. This is the low pass filter, and here is the Schottky rectifier. The output of the Schottky rectifier is fed to this comparator LM339, and one pin of the comparator is fed with this adjustable voltage. The output of the comparator is fed to this SL100 transistor. Let us look into the waveforms. So if we look into the waveform now, we can see here this is the output of this is the modulated signal, and this is the signal after the demodulator. You can see this is the modulated signal, and this is the signal after the demodulator. So let me compare the original signal and this signal together, then we will be able to know the status of the transmitted data and the received data. So now if we compare these two data, you can see the number of high pins, and you can see here they are the same data. So like this is the original data, and this is the received data. So like this, the original data is retrieved back at the receiver end. So this is how FSK signal works. This is how the FSK modulator and demodulator works. Thanks a lot. Thanks for watching.